Here we want to be able to find all complex zeros of the polynomial function and then give exact values, and we're going to list multiple zeros as necessary. So the first thing we need to do is determine what is p and what is q. Okay, so we know that p is the constant, which is 144. So in the numerator we have the factors of plus or minus 144 over, well, q represents the coefficient, so that's plus or minus 1. So technically we're just looking at plus or minus 144. Okay, so what are all the possible rational zeros of 144? Well, we have plus or minus 1, plus or minus 2, plus or minus 3, all the way to plus or minus 144. Now these are all possible zeros of this polynomial function. Now let's take a look at what this looks like on Desmos. All right. So we're going to go ahead and put this in here. So we have x to the fourth plus 40x squared plus 144. Okay, so if you take a look here, this graph is way up here. Okay, so it does not cross the x-axis. So therefore, these zeros are not going to be used to be able to determine this zeros of these functions, which means that because this is above the x-axis, that means we have imaginary solutions or imaginary zeros to this function. So we need to figure out another way to be able to do this. So what we're going to do is we're going to take a look at this function x to the fourth plus 40 x squared plus 144. So we're going to see if we can factor this, because this is actually a quadratic equation. So what this means is it's in quadratic form actually. So we have 144 and the value of b is 40. So what two numbers can we multiply to get 144? Then we add them together, it gives us 40. Well, 4 times 36, okay, that gives us 40 when we add them together. So 4 times 36, okay, gives us 144. When we add them together, it's going to give us 40. So what that means is the following. We're going to write this in factored form. So we know this x to the fourth means that we would have to multiply both of these by x squared. And then we have x squared plus 4 times x squared plus 36. Okay, now we need to find the zeros. So we're going to set this equal to 0. So we have x squared plus 4 times x squared plus 36. And we're going to set that equal to 0. So we have x squared plus 4, which is equal to 0, or x squared plus 36, which is equal to 0. So we're going to subtract 4 to both sides, so we get x squared, which is equal to negative 4. If we take the square root of both sides, that gives us plus or minus the square root of negative 4. So therefore, x is going to equal plus or minus 2i. Or we're going to subtract 36 to both sides, so we get x squared, which is equal to negative 36. Taking the square root of both sides, we get plus or minus the square root of 36. So therefore, x is going to equal plus or minus the square root of 36. Negative 36 is 6i. So therefore, here are our complex zeros. We have negative 2i, we have positive 2i, we have negative 6i, and positive 6i. So there are our 4 imaginary solutions. Let's go ahead and put that in here. So we have negative 2i, comma 2i, comma negative 6i, comma 6i. Let's check our answer, and there is our result.